happens. Now we'll see whether it cooks out and fails off on a voltage issue or not. You see our gas pressure right there is 7 inches, so we're within spec there on that. Now that it's running, let's see if it'll run now. You've loosened up that diaphragm in there. That's the problem you run into with these, is now it's going to start every time. So that's the reason why I checked my fuel pressure and stuff beforehand. So yeah, it's getting through the fuel regulator, but I do not believe it's getting past the bellows there. So I'd have to show you a diagram inside the book to kind of explain it. You can see how well this chassis is hanging in there. It's all rusting out. This is the reason why they went to aluminum now. Let's go ahead and pull this top. It's all metric, so the HVAC guys are so used to standard. You're gonna have to pick up a metric set. So let's go ahead and get that apart and let's check the voltages and see where we're at. I'm gonna recommend we replace the fuel regulator deal, and even though it's gonna start and run just fine for them. This one here has no dates or anything like that to remind them of when it failed in history, so there's no history whatsoever. I'm gonna go ahead and take my fuel gauge off here too. Okay, so we got everything picked up out of the way for the most part. This is where I like my cobalt ones. I've got a 7mm here. It's one of those universal ones that as far as it can do square and all that stuff. It seems to really get into the 10mm one here. I use the universal socket there, universal swivel. That way it gets in there. Let's go ahead and put these down here so we don't lose them. We'll take this cover off. There is live voltage in here, 230 volts. Once again, don't freaking do this crap if you ain't got a clue what you're doing, and then whine that you got freaking electrocuted or whatever. You've got your input voltage coming in here, N1, N2, that's where it senses voltage at. You have a transfer coil there, terminals 23 and 194, that's 12 volts DC going to the transfer switch to make it kick over. You've got your breaker here. This is protecting the voltage going to the house. You've got your dual tap transformer here. This is for the battery charge circuit. It takes the 230 volts from the house and turns it into 18 volts area for the voltage for the battery charger there. And when the generator's running, it uses the other windings for the battery charger. And then they use a relay to switch in between that, which they got rid of all that crap because they found out it was kind of dumb. Same thing with the voltage regulator. This thing's known for failing like crazy. If you got like super high voltage, 330 volts coming out, chances are that thing's fried. Here's your battery charge circuit. So anyhow, what we're gonna do now is we're gonna test the voltage and frequency to see where we're at. Like I was saying, I grabbed my cheaper 117 fluke meter. It's good enough for generators. Nothing real complex on waveforms or anything like that. We can check our DC voltage here. Let's go ahead and see what our battery's coming in at for charging state. We'll go ahead and go across here to there. See what we got. 13.6, so as you can see, it's a little aggressive. And let's go ahead and go to regular AC voltage and see what we got on that. 147 volts, that's nice. Go ahead and go to frequency. It's picking the frequency up, floating. Terminals aren't even on there. Before. Nice. I'm going to put that down here, see if we can get an accurate reading. My Fluke 87.5 don't do that. We're still running 58 hertz, which under a load it probably is going to modulate. There's nothing I can do about that. That's controlled by the control board. So voltage and stuff is fine. The only thing left to do now is to test the transfer switch to make sure it's actually going to transfer over. It doesn't do them a whole lot of good to have a generator running if it doesn't transfer over. And unfortunately, that's one of the most important tests at the end there you need to be doing. Let's do a rundown here. We've already taken care of the battery, so we know the battery's going to start. We made sure the water levels are correct. We made sure that a specific gravities per cell is the same, so we don't have one cell failing over the other. We got good connectivity on our battery terminals there, and we got those treated. We've checked our spark plugs and made sure that the gaps are correct. Prior to that, we checked our compression to make sure our compression was correct. And then we checked our battery charge circuit and made sure that we got the battery voltage coming into it, which is in the range that it normally runs at. And then we also tested the battery under electronic tester, and it showed that it was okay. We've made sure that our gas pressure is right. So just like anything, you got to have spark, you got to have fuel, got to have compression. You got to, you know, just take your basics there. Then, you know, there's other safety things in the circuit that can go wrong. You got oil pressure safety switch here that can go out. You got temperature switch down here on bottom. Some of these are normally closed. Some of these are normally open circuits. You got your servo here. I haven't had too many of those fail. I've had idiots leave the cap off and lose the oil all over the place. That can happen. Those are some of my main things, along with the voltage regulator there fail. And then that fuel solenoid down there, like I was showing you earlier, that has a tendency to stick, and that's exactly what happened here from what I'm seeing. As you can see, it is starting every time. And the only thing we did was gave it the 2-finger plunge, and it came right on and ran, and now that it's loosened up, it's working just fine. The voltage is coming out correctly. Like I said, the only thing we need to do now is do a test to see if it will transfer over. What we can do, we can unplug N1 and N2, one of them here, which, like I said, it's 230 volts. You're taking a chance of blowing a fuse. Those are only rated at about 5 amps. And when it does that, it's going to send 12 volts DC, which it usually switches the negative. It's always 12 volts on the one terminal. So if you came in here right now with your meter on DC voltage, and you come in to, I think well, either way, it's going to come through and out. So 23 to ground, nothing. Now if you go to chassis ground, which is going to be the same as battery ground, you got nothing. Let's go over here to 194. Maybe because I'm not in auto mode. Yeah, I'm not in auto mode. So let's go to auto mode. We have a green light, solid, which means that it's programmed for some specific date. Let's go back here to 23 and chassis ground. There we go. Now we're at 13.68 there on that one. And we come over here to this one here and do the same thing, 13.68. So what it's doing is it's looping through the coil of the relay inside that it uses to transfer it over. I have my leads backwards here. So if we put the positive on the 194 or in to chassis ground, we've got the 13.69. If we go to neutral, probably won't get as much. Let's go there to it. That's still there. So they must be commonly bonded together of some sorts. So anyhow, yeah, so we've got it there. Now, if you check between the two of them, you won't have anything. So we go between those two and we have 0. When we trip this thing out, it should say 13 or so volts, and that's going to power the transfer switch, and you're going to see the motor bogged down. Now what we can do is we can literally leave it in auto position. We can unplug the plug in here. Sometimes this is easier. We got a 5/16 screw holding that plate on, and there's a Molex plug. And if we unplug the Molex plug, that's going to kill the 230 volts, 240 volts coming into the generator, and then it's going to start up and it's going to transfer the DC voltage to the circuit inside if it was connected. But since it's not connected to it, it's not going to do crap. So let's go ahead and put it on AC. Let's check our incoming N1 and N2. And obviously it must be right because we don't have blinking light. So there's 246.5, give or take a few thousand volts. We are good to go there. Kind of find this humorous. I get down here and I see my writing. It says wire nuts. Somebody was an aggressive fool and snapped off, oh, that's nice, bees nests and everything else. They snapped off the terminals up there when they were installing it. And then they, ooh, there's some live ones in there. Look at him. Yeah, he's not moving around real fast, but he's in there. See him right there? He's sleeping a little bit. It's not that freaking cold out. Anyhow, our plug that I wanted originally is up there at the top. Let's see if I can get that out of there without having him come out and kiss me. Get this out of there. Okay, there's our terminal, which that's all jimmy-janged, hem-hoggled, flambasted, whatever you want to call it, together. That's the plug there. He's flying around. That's nice. Let's go ahead and pull this apart. It's going to start after about 10 seconds, and then it's going to send out 12 volts DC. When I put it back together, when I'm done, it should transfer over, and it's going to wait about 10 to 20 seconds, 30 seconds, and then it's going to start cooling down, and it'll undo the 12 volts. So in reality, I'm going to get it to switch without having to kill power in the house. Finally got it apart. There we go. She should start up here in a second. Should see blinking light over here. Yep, see the blinking green light? So it just started up. Generator should be providing voltage now. Obviously, we checked that earlier. 247, great. Go to AC volt or DC voltage. Go down here to 194 and 23. 13.2 volts. So we're transfer switching over. Positive is on 194. 23 went to ground. Obviously, you can see our red, black there. So we did that. Now watch this. When I plug this together, it's going to allow that voltage to go in there and transfer over. But it's also going to start counting down that it's got power. It should have kicked over. I didn't hear much of a load. The only way to know that is to put the amp meter on there and see, but chances are it's already switched off. Yeah, it didn't do anything. We can undo it again here. That way it kind of switches over. Something there, so it did transfer over. There's a generic way of doing it, probably not the preferred way of doing it. It's easier if you can go inside and pull a fuse or turn off the main breaker. Myself personally, I usually like to pull an N1 or N2 fuse. That way it starts up, transfers over. You've got utility voltage there, and you've got generator voltage also. It just switches over. You have a little bit of a blink. You don't lose your computers. You don't lose you know, your clocks on the radios, whatever, and usually you're fine, and you can transfer back. It should shut off here in a second. All right, she's coming to through its 1 minute cool down area, and it switched over. I'm pretty satisfied with what we've got here. Like I said, it transferred back and forth, and we've pretty much already checked all the things that I've already gone through several times here. Those are the things that we checked. That's what we did. I'm gonna recommend we replace that fuel, whatever you want to call it. I forget. They call it something stupid. It doesn't even really sound like what it is. But either way, it's not really the solenoid, but it's more of the fuel regulator. We'll go ahead and stick that back in there along with all this other goodness, and let's see if we can find that screw. Got that in there right now. We're good to go there. All right, guys, hopefully you enjoyed the video. If you did, hit the thumbs button. Check out some of the other videos. I've got other generator videos and HVAC and refrigeration videos. Check them all out down below. Check us out on Instagram, Facebook, and until next time, guys, we'll catch you on the next one. Later.